So I want to welcome you to the IoT and Edge at Eclipse. This is a collaboration with Eclipse IoT and Open Continuum. Before we start, I want to tell you that we are recording this meeting. So I also ask you to please mute your microphone and to turn off the video. And then if you want to ask a questions are very welcome, but please raise your virtual hands or add the question to the chat. Today we are going to have some presentation, but we will start with the first presentation, that is building on the momentum of open source, given by Gael Blondel, that is our Chief Membership Officer in Eclipse Foundation.
Thank you, Rosaria, for the introduction. Thanks everybody for joining. I will be short, because I think that some of you already listened to me last week when we had this EU Edge to Cloud Continuum webinar. And my message is definitely very similar today. So the point is really that, okay, open source and the way open source impacts our technical world has dramatically changed in the last 10 years, I would say, or 20 years, from being that started with a commoditization strategy, with a strategy where the goal is to have as many contributors as possible to reduce the costs. And that's when the first generation of successful open source projects like Linux, the Eclipse development tool, the Apache server, etc., were successful. But in the last 10 years, it really shifted to something where it's more about innovation and using open source to push innovative technologies. And you can see it in the examples here. That's really about all the big data projects at Apache are in this category. PyTorch and TensorFlow, if you think about artificial intelligence. Kubernetes is also a very good example. And that's something to keep in mind in everything we do in this project. So there is one aspect, is that open source is eating the world, and potentially faster than software has been eating the world. So that's really amazing how much of open source components are now components of all the applications we write and use every day. And that's certainly a big opportunity for Europe, especially in the edge to cloud continuum domain, because if you think about it, it's certain that the machine economy, the platform for the machine economy, will be open source. And with the project, with the NebulOuS project, and with all the projects related to Open Continuum, we have a chance to move the needle in what Europe will be proposing to the rest of the world in terms of open source platforms. But I think that one big topic is to avoid to have too much fragmentation, because when we have too much fragmentation, of course, it means that we spend lots of time reinventing the wheel, and that's really and our point today is really about and that's the core of the presentation from Philippe about breaking the silos. But our point today is really about collaborating rather than competing on the core components. And maybe my last two slides, that's really just to explain how we enable organizations to collaborate on platforms with our legal framework at the Eclipse Foundation, and how we enable different organizations to build business models on top of those open source platforms. So that's all about, having a proper governance layer. And that's very important because doing open source as we see it, and as we want to help you do it with Open Continuum, is not just pushing code to GitHub or GitLab or whatever place. It's really about setting up collaborations and using a vendor neutral governance and open source best practices to enable such a collaboration layer. And that's really what we call the collaboration layer here, is really having different organizations, even sometimes competing organizations. And by competing organization, I mean competing research organizations or competing industry players, collaborating together on a core platform and really building the best platform that will enable everybody to build their best use cases, or to create new startups, or to create new business lines on top of the platform. And just to keep it short, that's really how we have a chance to get leadership, to push European leadership in those technologies. Everybody is using open source. Most of us and most of you are contributing to open source with the idea that if you contribute to open source, you have a chance that your bug fixes, for example, will be integrated in next versions. So that's really contributing. It starts usually by, I don't want to apply my patches every time. But the point, and what we will try to do together, is really to take the leadership in the edge to cloud continuum platform, and to push European leadership in this domain. Thank you very much.
Now, a very short presentation where I really try to put more context on why we decided to organize this webinar. Of course, we also invited other people, but mainly we'll talk about the Open Continuum cluster. So six projects, and it's really about breaking the silos and the future European platform for the age. So as Gail mentioned, open source is hitting the world, but you can see also from the top side, you can see that we're standing on the shoulder of giants. So we are based, all our development, all our research are based on lots of open source code. So 80% are developing based on open source, but even the results of this development, it's covered by 80 to 90% of open source. So it's very important to be aware of that. And usually, and it's all about collaboration that Gail was talking about, is we are building an open source, usually an open source platform that where we base our product on top of that. And usually the idea is to have 20% of our team working on this common open source platform, and 80% of the team working on innovative ideas where they can compete with others. You should not waste time in trying to invent in silos, everybody is on code and reproduce the core protocols and so on. So it's for this reason that people are building open source. And to achieve that, and also as Gail mentioned, you need to have a vendor neutral organization which is able to provide you an infrastructure for open collaboration, help you building an ecosystem based on some existing ecosystem if possible, having a strong governance and processes to ensure you that the code that you are developing will be always shared with everybody, and not at some point somebody will steal it for his own needs. And we have so many examples of that. That also you need to have some IP review, because as soon as we talk about open source, we talk also about licenses. And last but not least, it's something that recently Eclipse also put in place, is deliver a supply chain security service where people will be able to verify that, yes, the full process to develop their solution will not generate some vulnerability. For example, by somebody could inject some vulnerable code or some virus in your final application. So In what we saw so far with Eclipse, and we're involved now for almost 10 years in research projects, and it's the first time that we have a chance to be in a CSA. It's that usually a research project, even when they are on the same topic, on the same cluster, they build their own solutions, their own story. Very few of them try to collaborate with each other. So we find at the end several silos with great projects. Some of them will survive, will sustain, some of them will not. And it's really a shame that when they sustain and when some projects don't sustain, then we might lose in these projects maybe some what I used to name golden nuggets, which could be reused by others because it also answers pretty well to the need of the code. So the idea that we have here, here's how we see today the world, where all these projects, all your projects are based certainly on open source solutions. So everybody will have his own open source stack and isolated. And what we try to do is to have this kind of solution where all these projects will be able to define a common open source stack and core, at least a core one. And then after maybe by subgroup, by sub-project, to define sub-common open source stack and work together on this common open source stack. So like that, we increase the chance of collaboration, we increase the chance of interoperability, and we increase the chance of keeping some golden nuggets survive. And the role of at least our task in this CSA, Open Continuum, is to help you achieving that. And today is the first day of this kind of action. So definitely, if you want to avoid isolation, avoid the loss of these golden nuggets, and promote interoperability and build a large community instead of having to fight separately on each different project, I invite you to really participate in this cluster. Not only with us, it's one of the objectives of this cluster, but with all the other, of course, partner of this CSA, to help you achieve the objectives that we define on this CSA. My last slides to give you an idea of the approach. Here we are starting to share our visions and architecture. We'll see at the end of these presentations the six different projects who will present their current architecture, at least what the big ideas they have coming from the DOA or even more. And then we'll start doing the work in January to identify common parts. And we also certainly start identify some missing open source part that people are looking for, and they might be able to find on different other projects. And based on that, we expect to be able to define by middle of the year 2 to define our common stack and start delivering some document, not only a white paper, which is something that really we have in mind, is to be able to provide some recommendation, but this white paper also will be used as a documentation for the coming open calls, because as far as I know, most of these 6 projects involved in this cluster are planning to have open calls either during the first year or second year. So it will be very helpful, and we expect to gather some feedback from this open call to improve the white paper that we wrote during the year 2. So for your information also, please keep the date. January 18th, we organize this first workshop in Toulouse, where we'll work together in defining and understanding a little bit more the different architecture, and already start having a good idea of what are the different open source components that each of us are planning to base our development, and expect to see some common stack, or maybe adopt some common stack if it makes sense to us. So keep the date the 18th, and we'll send you all the information to book your plane, your stay, and so on. And we hope it will be very fruitful meeting. I'm done, and now I give the hand to our colleague Frederic, and thanks a lot, Frederic.
Thank you everyone for being here today. It's a great pleasure for me to be here. So as Philippe said, I'm Frédéric Desbiens, or Fred. I manage IoT and Edge computing programs at the Eclipse Foundation. And today I will try to give you a teaser about Well, the main parts in our IoT and Edge computing toolkit at the Eclipse Foundation. Now, there's a lot of content in this presentation, okay? I don't want you to be scared, because essentially the one message, the one thing I want you to remember about this presentation is that if you need help in selecting the right components for your project, I'm here to help, okay? The whole point is for you to leverage those building blocks, as Philippe and Gail explained, to accelerate your research and really innovate at the top. So not reinventing the wheel on commodities or things that have already been done, but really, you know, push the envelope and really do meaningful research. And I'm here to help. So that's the one message I want you to remember. So yeah, there is in this talk information about the foundation, you know it. One thing I want to highlight is really that IoT and edge computing is really one of the 4 strategic pillars that we've got at the Eclipse Foundation. Okay, so this is not for us a sideline. This is not something that we dabble occasionally in as you know, as newbies. We've been doing IoT at the Eclipse Foundation for over 10 years now. So the Eclipse IoT Working Group has been created in November of 2011. So we were celebrating the 10th anniversary last year. So what I'm covering in this presentation is really a mature toolkit, you know, technologies that have been proven in the real world, in, you know, hundreds of thousands of real world deployments. Well, not necessarily all of them. Some of them are more mature than others in the toolkit, but you see the idea. So we are taking IoT and Edge very seriously at Eclipse. So one important thing may be just to contextualize all of that as well. So I'm covering in this presentation many open source projects, and I will mention also our 3 working groups that we've got, which are Eclipse IoT, Edge Native, and Sparkplug. And there's a big difference between the two. So open source projects are literally that, people writing code in repositories, typically on GitHub. Some of them are on the Eclipse Foundation's GitLab, but whatever place, open source projects are about committers writing code, and they are all of those projects self-contained meritocracies, okay? So they set the technology direction, and of course, Foundation staff will have advice to them to give about following the Eclipse development process, being open, that kind of stuff. And certainly I can contribute technical opinions if they want my opinion, but ultimately it's up to the projects to set their technology direction, and we, the staff, support them in realizing their technology vision. And then on the other side, we've got this concept of working groups, and working groups are organizations coming together to promote the use of specific Eclipse technologies. So that's why we have those 3 working groups in the IoT and Edge domain, because on those specific teams, people wanted to get together, set a vision, and then evangelize the market for that particular vision. So projects can be linked to any number of working groups. Working groups decide which projects they take an interest in. So they are fully decoupled from each other. And so this is something important to remember when I talk about projects and working groups in this particular presentation. So this is the list of, and it's not even exhaustive, but of our current working groups. But in this presentation specifically, as I mentioned, we cover IoT, Edge Native, and Sparkplug. So in the IoT and Edge domain, what we did, we tried to align, because the thing is, we have 50+ open source projects in the IoT and Edge domain overall, okay? And some of them are very popular, some of them are very small and not as active. So we wanted to give ourselves a way to provide a map of our ecosystem to newcomers like yourselves, okay? And what you see on the screen is really this kind of reference architecture that we are using throughout our projects. So as you see, there are 3 pillars there: constrained devices, edge nodes and IoT platforms that typically will run in the cloud, but you could deploy them, of course, on a local node or in your own data center. We don't have any ties to any specific cloud, but you can run all of those platforms in the cloud as well. And of course, there are layers that are common throughout those three pillars. So specifically protocol implementations and of course, connectivity options. Typically, connectivity is provided by hardware. So you deploy a node with Wi-Fi connectivity or Zigbee or maybe LoRaWAN, those kind of things. Anyway, so typically this is handled by hardware, but for the sake of completeness, we put it in the reference architecture. So this is the abstracting. And on the next slide, you see the logos for the 20 to 25 most active and popular projects in our ecosystem. And you will see we have logos in most categories. So the whole point for you is not, to try to make out all of those little logos there, but just to impress on you how comprehensive the toolkit is. Okay, and in some categories it's a bit thinner. In some categories it's a bit more expensive, but overall this is a comprehensive toolkit. And as I mentioned, my job is to help you figure out what you can leverage to innovate at the top and push the envelope in terms of research. And you will see at the very bottom in the hardware layer, it's very small, but I have the logo there of the Open Hardware Group. So Open Hardware Group is a kind of sister organization to the Eclipse Foundation. They are focused on open source hardware, and specifically, they are developing on GitHub open source processor cores implementing the RISC-V instruction set. And when I say open source, it's literally that. You go to the GitHub and you can download the definition of the cores in System Verilog, a programming language which is used in chip design. And you could take that to a foundry and get 1 million of those chips done if you wanted to. So really, we are trying to build this comprehensive ecosystem, open source, all the way from the microcontroller to the IoT cloud platform. And so if you are interested specifically in Open Hardware Group, some of those processor cores have been initially created at ETH Zurich in the context of research projects. So if you want to push the envelope in hardware design, of course, we can put you in touch with the team at Open Hardware. So I mentioned them, but I'm no chip designer, so please spare me pointy questions about how this works. Thank you. Okay, and if you want a more detailed overview of what I just covered, the reference architecture and the content of this presentation, I wrote a book which will be available at the end of the month. I just finished reviewing the proofs. So they are literally busy printing copies right now. So by the end of the month, it will be available everywhere. I think you can pre-order in a number of online bookstores already. If you want the full story with the code examples for most of the building blocks that are covered in this presentation, then this is the book for you. And that's certainly a marvelous gift for Christmas to your significant other or children, if you want to get them to sleep. Okay, excellent. So let's start with the Eclipse IoT working group and the projects that are in there. So the goal of the Eclipse IoT working group is really to provide building blocks that help you build IoT solutions, okay? So nothing in what I will cover is a full-blown, fully integrated, pre-configured platform, okay? Those are building blocks that you use in order to define your own platform, but in there, some projects are more integrated than others, and of course, when they are integrated like that, it's a faster way to production, so to speak, in your case. So certainly, if you are in a hurry, looking at those pre-integrated or those projects that are developed together would be a good idea. So in Eclipse IoT, we care about, of course, constrained devices or connected things and IoT cloud platforms. And well, you will see that there is some interest in Edge as well, although we have a fully dedicated Edge working group. So this is the current membership in Eclipse IoT. So we have 3 leader members. So the ones that contribute additional money and define the vision, Bosch, Eurotech, and Red Hat. And we have 2 innovator members in EMQ and HiveMQ. So in their case, certainly they have an additional level of commitment. And then you have the rest of the membership, and you will see there very small startups like Aloxy, a Belgian startup connected to the University of Antwerp in Flanders, working on solutions, IoT solutions for the petrochemical industry. And then you have large players like IBM, and you have nonprofits like the Linux Foundation and Open Robotics. So as you see, very diverse membership with small organizations, large organizations, and of course, some research institutes and academic institutions as well. So let's start now figuring out what's in the toolkit. And we'll start with this common layer that I told you about, IoT protocols. So at Eclipse, we have a number of implementations for all of the leading IoT protocols that you can think about. So we have Eclipse Californium, which is a co-op implementation. We've got Cyclone DDS for DDS, Lesson and Wakama for lightweight M2M, Eclipse Milo for PCUA, and 2 distinct MQTT brokers in Mosquito and Amlan. And then we have the collection of MQTT clients, Eclipse PAHO. So, you know, for the next few slides, I will cover in detail the properties of most of those protocols so that you can figure out what could be a good fit. But remember, this is only part of the story. We have a homegrown edge computing protocol that I will cover a bit later. So in the case of CoAP, CoAP stands for the Constrained Application Protocol, and really it's a specialized application protocol for constrained devices derived from the concepts of HTTP. Okay, so what's great about CoAP is that if you're familiar with HTTP, you will understand the model quite easily, in the sense that CoAP is a request response protocol. So you use get, post, put, and delete like you would do in HTTP or when using REST APIs. And it supports URIs, response codes, MIME types, exactly like HTTP. Of course, underneath, the goal of CoAP is to reduce the size of payloads and the bandwidth consumed. So it is a much lighter weight than HTTP, and really interesting for that. In fact, typically CoAP can run, will be run over devices that support UDP or a UDP equivalent. So you don't have necessarily delivery guarantees or anything like that, but there are mechanisms in the protocol that enable you to have some level of quality of service if you choose to configure things in that way. So what's in there? What does CoAP offer you? Really, CoAP is interesting because it's an asynchronous protocol with low overhead. Everything is very simple to parse. And then, of course, given that it's based on HTTP, if you have HTTP proxies, HTTP caching servers on your network, you can use them to cache or proxy CoAP traffic as well. Typically, that's not very difficult to add. So let's say that in terms of easy deployment into existing architectures that are based on HTTP, CoAP fits there quite well. And here you see the protocol stack. So typically, of course, you will run CoAP over traditional Ethernet or Wi-Fi networks, over IPv4 or v6, but you could also deploy a Bluetooth mesh, and then using 6LoWPAN, which is a protocol that enables you to run IPv6 over a Bluetooth connection. You could run CoAP that way over a non-IP network, because Bluetooth doesn't support IP out of the box. You need 6LoWPAN in order to do that. So our CoAP implementation at the Eclipse Foundation is Eclipse Californium. So Californium implements a whole bunch of standards because CoAP is under the stewardship of the IETF, so the Internet Engineering Task Force, and most of the core protocol and its extensions are documented into those specific RFCs that you see listed on the slide. I skip on that because that's a bit too pointy. However, excuse me? Oh, okay. I thought there was a question. So what's interesting in the Californium implementation is that it comes with an HTTP to CoAP cross proxy. So you can mix and match in a single application CoAP nodes with HTTP nodes if that's something that you want to do. So Californium is a mature implementation, well-maintained, and certainly worth of your time. It's in Java. So if you're using other languages, unfortunately, you could use it anyway, in the sense that Californium provides a CoAP server and a CoAP client. So you could use the server with clients written in another language, for example, without any trouble. Next comes the Data Distribution Service, or DDS. So DDS is a completely different beast from CoAP. It's really a machine-to-machine pub-sub protocol, publish and subscribe. And really, the focus there is to decouple applications from each other. So any node in a DDS infrastructure can be a publisher, a subscriber, or both at the same time. And it's already very popular in specific verticals. You will see it a lot in aerospace, defense, autonomous vehicles, robots, and applications like that. And the spec is owned by the DDS Foundation, which is a component of the Object Management Group. So DDS really provides spatial and temporal decoupling for applications. So in other words, applications can be fully distributed, and they can communicate asynchronously. They don't, the nodes don't necessarily need to be online at the same time. If nodes disconnect from time to time, they will get, if you configure things right, they will get the messages that have been sent while they were out or disconnected or sleeping asynchronously. There's no problem there. There is no single point of failure in DDS deployments, because essentially this is a peer-to-peer model. So every node will route traffic for the neighboring nodes. And the quality of service policies in DDS enable you to express specific constraints about timeliness for delivery and availability and things like that. But it's a very granular model. So, it's a bit complicated, but, with that level of granularity, you can tweak DDS infrastructure to deliver exactly the type of quality of service that you are expecting for your application. And another great thing about DDS is that you don't need to know in advance what the topology of the network will be, because nodes, the protocol essentially provides automated dynamic discovery for neighboring nodes. So essentially, you just have a new node join the network, and it will auto-discover where are the neighboring nodes in the infrastructure. So no configuration needed. And of course, this means if IP address changes or things like that, then this will not break the application. The nodes will adjust and rediscover each other after a short downtime. So this is the stack for DDS. So once again, DDS can run on typical Ethernet or Wi-Fi networks over IPv4 and v6. And you have the choice to run it over TCP or over UDP. So if you want a bit more robustness, you will go towards TCP. If you want to save on battery life, then UDP is maybe a better choice. But in any case, the quality of service guarantees offered by the protocol are still valid, whatever transport you choose to use in the lower layer. So our implementation of DDS at Eclipse is Cyclone DDS. So it's written in pure C with minimal runtime dependencies. So, it doesn't pull, tons and tons of third-party libraries to operate. It's very compact. It can fit in about half of a megabyte of memory. and it supports all leading platforms, macOS, Linux, Windows, etc. And if I remember well, BSDs are also supported. And what's great about Cyclone DDS is that it's been recognized as a tier 1 middleware in the ROS2 operating system. So ROS2 is heavily used in robotics, and Cyclone DDS is the default implementation of DDS used in ROS2, because ROS2 has this concept of middleware built in, and they selected DDS as the default protocol, and Cyclone is the default DDS implementation that you can use in ROS2 at this point in time. Now switching gears a bit and moving on to lightweight M2M. So lightweight M2M is a higher level protocol that really focuses on sensor networks and machine-to-machine environments, and it uses CoAP as a transport. So essentially when you use lightweight M2M, you are running over CoAP, which itself can run, of course, over TCP or UDP at this point in time. What's interesting about lightweight M2M is that it defines a resource and data model. In other words, the specification is owned by an organization called OMA SpecWorks, and OMA SpecWorks will define what they call resources, which are predefined, pre-configured, and standard models that represent typical sensors or other information found in deployments. So for example, if you have a temperature sensor, you can look in the OMA SpecWorks repository, and you will find they have a standard definition for that, for example, that you can use and implement. And the advantage of that, of course, is that when there are other lightweight M2M implementations, if you use those standard resource and data models, then other applications will be able to consume them right off the bat without any further work from your part. At the same time, it's extensible because, of course, you can take the standard definition in the repo and then add your own properties to any data, any model really that's provided by OMA SpecWorks themselves. And you can even, as a third party, submit your own resource or data models to OMA SpecWorks for integration in the library. So this is something we've done in the past at the Eclipse Foundation for our lightweight M2M implementations. So what's interesting with lightweight M2M is that it's a higher end or higher focused protocol compared to CoAP. So it offers lots of value-added features like device bootstrapping and configuration, pushing firmware updates, management of faults, configuration and control, reporting. So as you see, we are not so much in low-level technical details, but really in value-added features that can speed up your deployments in the field. So this is the lightweight M2M protocol stack. As you see, lightweight M2M supports a wide variety of transports. Of course, UDP and TCP are in there with or without TLS, but you can use it directly over a LoRa connection. You can use it even over text messages. So that's why you see SMS on the stack. So really, it's highly flexible and certainly worth of your attention if you're looking for a protocol. So we've got two lightweight M2M implementations at the Eclipse Foundation. So Eclipse Lesson is a library for implementing clients or servers. So it's just a library, but they ship a sample server and a sample bootstrapping server that you can use in order to build your own as well. And this code is very well polished, and it comes with a web UI. So even if you're writing your own server, you may want to use the Lesson test server in order to explore the properties of the devices on the network, for example. It's really useful to that. It's very simple with no dependencies in terms of code. It's not using any third-party frameworks, and it's based on Eclipse Californium. So you've got a full Eclipse stack in there. So that's for Lesson. As for Wakama, it's a C client implementation of lightweight M2M. Some people even embed it in server types of applications as well. It's written in portable C, so it will really lend itself to any environment that can support the POSIX APIs really. And last but not least is MQTT. So MQTT is a publish and subscribe protocol that can run over low bandwidth networks. And it's been around for quite a while. It's been created in 1999 by Arlen Nipper and Andy Stanford Clark at the time. And MQTT can run over TCP, but the MQTT SN variant, it's really a distinct version, but it uses the same semantics and this, most of the same basic mechanisms. It can run, in the case of MQTT SN, over UDP. So this is a publish and subscribe architecture, and the specification is owned by Oasis. So MQTT offers several quality of service levels. So you can get at most once, at least once, or exactly once delivery for messages, which is highly useful, especially if you have messages that must absolutely be delivered and at the same time must not be delivered more than once. Then quality of service level 2 is very useful to that. You don't need to implement that in your code yourself. MQTT supports persistent sessions, what is called also retained messages. So essentially, if a device disconnects, the MQTT broker will keep the last good message on that particular topic. And so if a device connects, although the original publisher is gone, they will get the last good known value for that specific topic. MQTT also offers something called last will and testament. So if a device disconnects abruptly, then the broker will send a message to every subscriber, and that message can contain information that will inform the subscribers to a specific topic that the original publisher is gone, for example. So with MQTT, you know at every given moment in time, if you make use of last will and testament, whether the original publisher is online or not. And in some applications, this is really useful. And there's also this notion of MQTT keep alive. So you can keep the MQTT connection over TCP open with a kind of built-in heartbeat mechanism. So if you don't want those connections to close and then have a reconnection with a new TLS handshake that will waste battery life and things like that, then this is a very useful feature to deploy. So the protocol stack for MQTT is quite simple. As I mentioned, you can run MQTT over TCP only, but the MQTT SN variant can run over UDP, and then you have additional savings for battery operated devices. So we've got plenty of MQTT related infrastructure at Eclipse. First is Eclipse PAHO, which is a collection of MQTT clients in several languages that target multiple platforms. And the feature set is really extensive, but the actual features in a specific client will depend on that particular implementation. So not all clients in the PAHO collection support all of the possible features, but the Java, Python, and C versions implement every feature that's available. To give you an example of how popular PAHO is, the Python version is in the top 5%. So Eclipse PAHO is in the top 5% of most used Python packages available in the Python package repository. So it's quite a popular project. And then on the broker side, we've got Eclipse Mosquito, which is a lightweight MQTT broker written in C, very portable. It's already available in most Linux distributions. So if you run Linux or Mac OS, you will type brew install Mosquito and you will get it. I mean, it's really everywhere and a very mature and well-maintained project. And then we have, if you are looking for a higher hand broker capable of horizontal and vertical scalability, clustering, high availability, and even integration with Java-based infrastructure using Java message service and things like that typically are found on application servers, then Eclipse AMLN is your best option. So it's really a broker that was used in IBM's IBM commercial products, most recently in their Watson IoT gateway broker. And IBM continues contributions to the projects. It's not because they contributed to the Eclipse Foundation that they deserted it. And really, it's a rapidly maturing project. It's based on code that was initially written for commercial products over roughly 10 years ago. Maybe I'm a bit wrong on the time frame. Maybe it's 8 years. Anyway, this is mature code. And certainly well worth of your attention if you're looking for a high scalability broker, whereas Mosquito is very good for lightweight use on constrained devices. So both of them don't really compete in the sense that certainly Amlin is the enterprise-ready MQTT broker, and Mosquito the lighter one that you put on constrained devices in the field. We also have and this is it for protocol implementation. So now my focus in the rest of the presentation is on IoT platforms. So we have first what we call the gateway and devices stack. So the two projects that you see on this slide, Eclipse Cura and Eclipse Kapua, are really developed together and pre-integrated together. So Cura is a solution for IoT gateways. It uses the Java programming language and OSGI to package things. And really, it enables you to build IoT gateways from commodity hardware over the Linux operating system. So you pick a ruggedized computers with the field buses that you want to use, you install Linux on it, and then you install Cura, and bam, you have a gateway that will support CoAP and MQTT out of the box and other protocols as well. And then you can use as an IoT cloud platform that goes with it Eclipse Kapua. So Kapua is a modular IoT cloud platform, and really it is capable of device and data management. Okay, and it's directly able to support Cura gateways. So if you want to manage a fleet of gateways using a mature solution, then certainly the Cura and Kapua duo are certainly well worth your attention. So this is the architecture for Eclipse Cura. So lots of details in there, but what I want to impress with this diagram is that really Cura is a fully featured solution that integrates with a variety of hardware and provides lots of value-added features, like, for example, you can run a database, you can run containers now on Cura, and even it's got, in the latest 5.2 version, it's got support for AI at the edge type of scenarios built in. So really a very useful component. And then we have another stack which comes to us from Bosch. Well, not only Bosch, but was contributed initially from Bosch. And this is what we call the digital twins and connectivity stack. And really the point of this trio is to provide all the fundamental building blocks for a highly scalable platform that will expose digital twins, that will provide device connectivity, and provide rich support for over-the-air software updates for devices in the field. So Eclipse Ditto is a platform that exposes APIs to manage digital twins. So essentially, there's a REST API that you use in order to create instances of your digital twins and then access whatever their state is, okay? And it's got a very rich access control model, so you can set a very granular security rules in order to ensure that data will stay confidential if you have sensitive data to manage. And then Eclipse Ono is a high throughput device connectivity platform. So it exposes remote service interfaces that enable you to gather telemetry from devices over multiple protocol, whether this is AMQP, CoAP, MQTT, etc. And really it's able to manage a large number of devices in the field and integrate that to other backends. And finally, there's Hogbit, a very mature and really a success story in the industry, where essentially Hogbit enables you to manage your software updates. So essentially you define in Hogbit what they call update campaigns, okay? So the rollout of specific software updates to devices. And through selectors, you can pick okay, which devices will get a specific update. And there are mechanisms in Ogbit where you can stage those campaigns over a specific amount of time. Let's say you update 10% of devices, you check if there are problems, then maybe the other 10%, etc. So it's really well thought out and integrates with, since it exposes REST APIs, you can integrate that with industry standard automation solutions, whether it's scripting or even automation solutions in order to get your software the updates in the field. So this is the architecture for Ditto. So you will see that there is in the middle a kind of search service. So if you're not sure which of the the digital twins that are there, which one you can access, or which one would be the best fit for you, there's a full search API that you can use in order to figure out which of the digital twin instances is the right for your specific application. And really, Ditto supports a number of APIs and integrations, of course, MQTT, but also AMQP, and even direct integration into Apache Kafka. So if you use Kafka as a kind of data ingestion mechanism in your infrastructure, then Ditto will connect straight to that and ensure that the relevant data is reflected in your digital twin instances. And next comes Sparkplug. So Sparkplug is a bit different in terms of working group than Eclipse IoT, in the sense that, as you've seen, Eclipse IoT is a very comprehensive toolkit, whereas Sparkplug is tightly focused on one thing and one thing only, which is to bring interoperability to MQTT infrastructure, okay? Essentially, Sparkplug is the brainchild of Alan Nipper, one of the co-inventors of MQTT. And essentially, it's trying to solve a fundamental problem in MQTT, or rather, not necessarily a problem, but let's say a gap in the protocol, in the sense that what makes MQTT great is that you can publish any payload to any topic. And what makes MQTT bad is that you can publish any payload to any topic, in the sense that in advance, okay, you have no idea what the payloads will look like and where exactly they will be published. And so this means, let's say you have devices, robots, PLCs or things like that, that you want to integrate, and they speak the MQTT protocol. And then on the other end, you have your software that speaks MQTT as well. You will need to figure out how to integrate all of that before everything works. And this means massaging the payloads. This means figuring out what the topic structure is and maybe bridging those things. And there's an integration effort. This is error-prone, time-consuming. So the goal of Sparkplug is to solve that particular problem by defining a set of standard payloads, a set of standard topic structures, and stateful session management on the top of MQTT. So MQTT is used as the transport there. And really the goal is to standardize everything. However, when I say standardize, okay, this doesn't force you to use a specific data model, in the sense that the payloads in Sparkplug are standard in the sense that they can represent any metric, but be parsed in a standard fashion by every Sparkplug device. So in other words, okay, what's standard in Sparkplug payloads is the way they are structured, but you can represent any arbitrary metric with it. But a Sparkplug publisher and a Sparkplug subscriber, since they have this shared payload definition, will instantly be able to interoperate. And it's the same with topic structures, in the sense Sparkplug expects you to place topics or structure your topics in a specific way, but it gives you some level of flexibility to reflect whatever topology you have in mind for your project. So this is the current membership of the Sparkplug working group. Of particular interest, since you are in research, is our member here, the University of Sheffield. So specifically, the Advanced Manufacturing Research Center at the University of Sheffield is using Sparkplug, and they built on the top of it something called Factory Plus, which is a framework for factory automation. And they are relying on Sparkplug as the base protocol in all of that. So certainly, if you are interested about the research work that they are doing around Sparkplug, I can connect you to the team at Sheffield if you are interested. So Sparkplug is an open specification at the Eclipse Foundation, which means we have a specification document and what we call a technology compatibility kit, or TCK. They are developed together in the same GitHub repo. The TCK enables you to validate the conformity of your Sparkplug implementation with the spec. And on the other hand, we have Eclipse Tahoe, which is an open source compatible implementation of Sparkplug. So if you want to just straight use that in order to bring Sparkplug awareness to your application, then this is something that you can do with the Tahoe project. And of particular interest is that we submitted 2 weeks ago now, we submitted Sparkplug as an international standard to ISO IEC JTC1. So we are expecting by sometime next year, if the ballot is successful, then Sparkplug will be an ISO IEC standard. And we have a compatibility program, but that's more for commercial implementers. Last but not least is the Edge Native Working Group, where we work together on edge computing platforms. And when I say edge computing platforms, that's either full-blown platforms or fundamental protocols that help you build such platforms as well. And really the philosophy there is to be code first. So we focus first on those platforms and then we care about architectures. So we are not working on abstract edge architectures or anything like that in that working group. This is really about specific platforms and real code deployed in the real world. And the philosophy around our efforts in the space is what we call edge ops. And edge ops is really interesting in the sense that, you know, DevOps really transformed the way that we build software and consume it. I mean, I'm using, for example, to build and present this slide deck, Google Workspace. And as I speak, maybe Google deployed updates on the back end, and maybe I will get a pop-up once I'm done with this presentation saying, hey, refresh your page, you will get new features. And that's great. It really transformed the way that we consume software, and the short lifecycle collaboration, CI/CD, microservice approach, all of that is very good. However, if you do that at the edge or for IoT types of projects, you will run into trouble. For example, if we are working on connected vehicle infrastructure, connected roadways, autonomous cars, you know, if everyone is on the highway at 4:30 p.m., that's not the right time to deploy a patch. You will have to wait until maybe midnight or something like that when there are less people on the road in order to patch the roadway infrastructure. And maybe you will patch every individual car when their owners go back home, for example. So, you know, DevOps and specifically CI/CD, that's an interesting approach. So at the edge, what you want to do is certainly continuous integration, getting new features all the time, but not necessarily continuous delivery, because then you have mission critical real-time types of applications at the edge, or even in the IoT space, where patching randomly could even kill people, for example, or provoke big accidents, or even in a factory result in heavy losses of production value. So essentially, edge ops is taking DevOps and adapting it for the edge. So it's taking into account the challenges that edge is helping you to resolve. So reducing latency, reducing bandwidth usage, increasing system resiliency, and of course, supporting data sovereignty. And then it takes into account the characteristics of IoT and Edge projects, the fact that the lifespan is longer than the typical IT project, that you deal always with heterogeneous architecture, the fact that you have those constraints about power consumption, cooling, water ingress resistance, etc., resistance to vibrations, etc. So all of that has an impact not only on the hardware, but on the software. So EdgeOps is taking that into account. And of course, the fact that connectivity is spotty in the field, you're not in a data center, so the network will go on and off or even degrade at random times, and you need to architecture around this. So essentially, EdgeOps is this idea that we take the basic principles of DevOps and tweak them in order to better fit IoT and Edge deployments. And in order for developers to be productive with it, we are building platforms that have EdgeOps built in. So, you know, you write less code to make, let's say, your code more resistant to losses of connectivity, because essentially the edge computing platform that you are using is providing useful features to simplify your code and make it more resilient to spotty connectivity, for example. So this is the current membership of that particular working group. And oh, I didn't put the product logos there. I was updating the slide because we have a new one. So sorry about that, but we are covering the projects in the presentation. I will correct the deck after I'm done speaking. But the first project is Eclipse IoFog. So Eclipse IoFog is container orchestration at the edge, okay? So it works on this concept of an edge compute network where microservices are deployed dynamically in the infrastructure, okay? So IoFog can run in standalone mode or integrate with a Kubernetes remote control plane for better integration. And what's interesting about IoFog is that by default, okay, no microservice can reach any other. You have to explicitly wire them in a functional fashion in order for things to work. So in other words, you have to write a little YAML descriptor that says that the robot telemetry service can speak to the historian database service. And you do that in a declarative and functional way, in the sense that you name the services, but you don't tie that to an IP address or anything like that. So even if the containers move around to different nodes or anything like that, you don't have to reconfigure anything, because essentially your microservices are wired at a higher level of abstraction together. So this is the typical architecture for an IoFog deployment. Here we have only 2 nodes, but you can see there's an agent running on the devices, and there's a kind of router and proxy that abstract the details of the networking from the microservices. And in standalone mode, IoFog will use the Docker runtime behind the scenes in order to run the containers. So this is well thought out, well understood and mature infrastructure that you are running. But at the same time, certainly IoFog is much lighter weight than what you would find, let's say, from even lightweight Kubernetes distribution. So for example, on a Raspberry Pi Zero, which is the cheapest and less powerful version of that particular board, you can run easily 3 or 4 containers along with the IoFog agent. Of course, you have to size those microservices to fit the hardware. So don't try to run your Hadoop cluster out of it or something. But certainly, IoFog is lightweight enough that it can run several containers on very constrained platforms in the field. So certainly a highly useful platform that you could leverage to manage the containers in your projects. And then another interesting project that we've got is Eclipse Zeno. So Zeno is not a full-blown platform, but rather a protocol, a pub/sub protocol, which is built from the ground up for edge computing. So it is inspired by DDS. So you get automated discovery, you get lots of the advantages of DDS, but what sets Zeno apart is the fact that it has built in for geographically distributed storage and distributed computations and things like that. So it's very cutting edge technology, and it is written in Rust. So you don't have memory overflows, you don't have race conditions in there because it's built on Rust. So this is an example of what a Zeno deployment would look like. So you see what they call selectors for the publishers and subscribers in the infrastructure. So in this case, I have a fleet of robots deployed in both Canada and France. So CA is for Canada. And then you see on the other end, I have fleet FR robot 1 for robots deployed in France and all of that. And by default, you know, Zeno is a peer-to-peer protocol, so the nodes will auto-discover whatever is in the neighborhood. You have this notion of a client which cannot route, you know, the traffic for other nodes. So it's lighter weight for very constrained devices, but clients will auto-discover whatever peers or routing nodes are in the neighborhood. And then there's this concept of a router node. That's really the place where you define the distributed databases, and you use that in order to shape the infrastructure. Router nodes can connect with each other in a fully encrypted fashion over the public internet. So, for example, if you have several universities or research institutes in a single project, you could have at least one router node in each physical location for the project, and they will all be connecting over standard ports over the public internet without compromising security. So this is certainly very powerful. Overall, we have other projects in from an edge perspective, and we care about what is happening elsewhere in the industry. So really, we see edge computing and specifically the edge as not a specific location, but rather as a continuum from the very edge of the device all the way up to the cloud. And so this matrix shows you Eclipse projects, okay, in color, and other projects that we care about in the edge computing ecosystem that are not at Eclipse. And as you can see, we've got very good coverage, and whatever we don't have on our own, we integrate with. So of course, for example, IOFog integrates with Kubernetes, and you can run Zeno applications over Kubernetes as well. And that's it for this particular deck. I know it's a lot of information. As I said, I hope I didn't scare you, but feel free to get in touch with me, and we can schedule follow-up calls and things like that to ensure that we figure out together what are the best components for your particular project. So that's part of my job, and I will be happy to help. So thank you very much for listening.
Thank you so much, Frederick.
Frederick, we have a question.
Yeah, it's mine.
From
yes.
You. Okay, so if you can, please.
Yes, well, first, thank you, Frederick, for the presentation. It's extremely interesting, and as that we enjoy looking at technologies and what they do and what they can do for us, etc. I have enjoyed a lot your presentation, so thank you for that. I was wondering who can be part of those work groups that you have mentioned to try to contribute and be aware. It's reserved for Eclipse members, or it's open to the rest of people? How does it work?
So our working groups are reserved to Eclipse members. Now we have two distinct levels, I think, Yael, that apply to educational institution. But typically, you've seen the University of Sheffield, for example, in Sparkplug, and you've seen CEA List and others in Eclipse IoT. So we have academic members at various levels, and certainly they are welcome. But yeah, the working groups are reserved for Eclipse Foundation members, but we can, if you are interested, help you through the membership process and figure out what the right formula would be for you.
And we have several levels of membership, but academics can be associate member and can sometimes be guest members of working groups. So we need to have the conversation. And beyond that, it's we have a very not expensive membership for academics to be full featured, what we call contributing members of the Eclipse Foundation, for 1,000 euros per year, which is very affordable.
Mm-hmm. Mm-hmm. Okay. Okay, thank you for that. I will check, it's very interesting. And if we do have the opportunity within the structure of the project, etc., to be part there and contribute and also be aware of the current status and next steps, etc., that would be nice and fine. So thank you very much for that and for the presentation. And Rosaria, if this is okay for you, I will just take in the stage as it's my turn.
Yes, please. Please go on.
Okay.
And thank you so much. Thank you for the question and thank you for being here.
Great, thank you. Well, so I will try to just stick to 5 minutes to present the project. I am Ignacio Lacalle. I come from the Polytechnic University of Valencia, the southeast of Spain, and we are the coordinators of the project of aerOS, which is one of the projects under the Data 01-05 cluster of the Meta operating system, right? These are just some administrative figures of the project. It will last, we started on September this year and it will last till August 2025. We are 27 partners and we come from 11 different countries. And we also include a partner that comes from a non-EU partner, which is Switzerland. So that's something nice to mention. What do we do or what do we pretend in the project? I am under the impression that most of us will be introducing the project in the same way. At the end of the day, we all have similar goals, trying to design the operating system for the IoT Edge cloud computing continuum, right? In that regard, same as the rest of the projects of the cluster, we try to deliver this solution, trying to govern underlying hardware from different type of nodes in the underlying infrastructure. We have called these nodes infrastructure elements, and we will try to govern and orchestrate data, services, resources, and the network that these different nodes use and take advantage of them smartly, trying to deploy advanced solutions. So we have delivered virtualized service to enable this orchestration, to support what we call explainable and frugal AI that we believe are the future in regard with the artificial intelligence when we talk about the IoT and the edge, meaning using less data for having same or more, even more accurate prediction, and also making these findings and these algorithms explainable, also including, say, privacy concerns, etc. Exposing everything and making it as open as possible, trying to break silos and vendor lock-ins that we have had recently, including infrastructural services to address, say, the commodities that need to be there. If we are to design all-encompassing Meta operating system, it will need to include cybersecurity, trust, manageability, everything. Probably, I believe that we will have more things in common with some technologies that Frederick has mentioned in the IO folk and other tools that they have mentioned. So this is more related to that, governing from a higher level point of view, what is the continuum itself. We are planning to use context-aware tasks, software task distribution, intelligence closer to the event, abstractizing the resources, the underlying infrastructure, those hardware, virtual machines, trying to bring those cloud native principles of developing resources as you are needing them and being scalable to different workloads in different moments of time, etc. Trying to bring those concepts into the whole continuum, allocating the tasks and supporting the scale-level data economy, and bringing those principles of the data economy, data act, to what the Meta operating system is. And in addition, we aim at doing it. We will see if we manage to do it, and we aim at doing it as generic as possible. So it will be validated in several use cases we have defined, but it should be applicable in any application or any field that anyone would like to apply it. This is the high-level architecture we have designed. It's not at all polished. Actually, the architecture definition task in the project started to say a month and 7 days ago. So we are just roughly tackling this aspect, but we conceive the management of the continuum of having these infrastructure elements that we have mentioned, on top of which we will install the aerOS Meta operating system that will consist of several inner software modules that will interact with different capacities, depending of which type of node it is, and how close or how far it is from the data source generation, if it's in the edge or far edge or closer to the cloud, etc. Embed within this installation enough capacities and enough processes to let them communicate, let them run AI services, and say grasp these functionalities that we aim to deliver upon these different nodes, supporting AI, supporting network, trust. I know this is a bunch of buzzwords that I am just throwing at you right now, but we aim at, during the next few months and during the next 3 years, materialize this into concrete tested solutions. And we also hope to be here to tell this to you and find synergies to collaborate among each other. That's all. I guess I have been more or less concrete, and I will pass the floor to the next one. Thank you.
Thank you so much, Ignacio. Yes.
Okay, thank you. Well, this is just some slides introducing what the ICOS project is. As Neto was mentioned before, I think that we are on the same page because we're applying to the same goal. So the target and the objectives are quite aligned on all projects that are to be presented here. Just to introduce a little bit on the project, this is a 22 consortium project with many companies and universities, as you see here in the table. One important thing here to mention before digging into the architecture that we have so far is how we plan to validate the scenario. As Nacho was mentioned before, it's clear that the outcome of the project should be something that is completely agnostic of the vertical. So we should, I mean, what ICOS should be at the end of the day should be something that we can apply wherever we want. But we have two strategies for the validation. The one that is based on the use cases that are provided within the consortium, and the other one by the two open calls that are designed into the project. The four use cases are on the agriculture, railway, in current multimedia, as well as in energy management. These are the use cases that we plan to use into the project. And then we have two open calls, and we have two open calls because the project is structured into two iterations. The first ending at month 18. So we're expected to have a first delivery of what ICOS should be in month 18. And that's why we are running two open calls to validate different kinds of, contributions from the ICOS project according to what we are expected to deliver in each one of the iterations, right? Actually, our hope is to have 20 projects funded in these open calls. So we are supposed to be able to extend and to spread out what ICOS should be as much as possible. Okay, regarding where we are actually, as you know, project started in September, so we did not evolve so much in creating or designing or crafting an architectural definition. Of course, we can add some boxes here and there, but it's not yet completely clear how we plan to do it. It's clear what the challenges are. These are these 5 challenges that are included here in these blocks, right, on top of this high-level architecture. What is the main concept for ICOS? This layer definition, in the sense that we're considering 3 different layers that are supporting what ICOS should be, right? So we start with this sort of meta-kernel layer where we include all functionalities that we're expecting an OS should deliver. And this meta-kernel layer is enriched with a security layer that is the one that is responsible for provisioning, for security provisioning, for all these kind of security and trust management functionalities that are expected to be included in this meta-kernel. And both layers are enriched with an intelligence layer that is the one responsible for adding this sort of smartness into the decisions that to be taken by both the security that is feeding the meta-kernel and by the meta-kernel itself, right? Of course, this is supported by a set of systems. As was mentioned before in the presentation from Reddit, some of the technologies could be also applied here. I have the traditional shell, of course, some management procedures responsible or explicitly devoted to see how data should be managed. But what is important now for us, it's not as a project, it's not how we plan to do it, but to understand where we are. And in the last discussions that we are having within the consortium, what is now important is to define the wording. I mean, we all should be in the same page, in the sense that when we are talking about clustering, we are talking about federating, we are talking about integrating, we are talking about communicating. When we are talking about this kind of business words, we should be very clear in the same page so we all can understand the same, right? And this is where our current discussions are. And we are just summarizing here some of the discussions that we are having today on regards on ICOS, because this is the key points that should be considered to define what the architecture should be. We started just trying to identify what ICOS should be. Are we talking about a platform? Are we talking about a framework, a middleware, a tool, like a piece of code, service, whatever, right? How is this to be delivered, right? Then what ICOS should perform. I mean, should ICOS directly interact with infrastructure? Should ICOS be just, say, kind of connector with the systems or the operating systems that are running behind? Is ICOS responsible for directly interaction with infrastructure, just trying to discover resources, trying to manage resources, to manage hardware? This is an open question. Who the ICOS clients are and what leads to providers should be set. So this also work from the point of view of the potential user of ICOS, how we may participate in this sort of collaborative models where we engage users to contribute with resources. I mean, all these kind of, say, new add-ons to the systems that can be also used in ICOS. How is AI integrated in the whole picture? I mean, in this intelligence layer, how we may consider AI here to benefit from on the two other layers, I mean, meta-kernel layer and the security layer. What the deployment strategy should be? I mean, are we considering something that is centralized, decentralized, is distributed, is something that's peer-to-peer, is something that it's based wherever, right? So this is something that is yet under discussion. And finally, in this sort of summary is how the business model may impact the architectural design. I mean, if is there any kind of constraint that is to come from the potential exploitation model or business model that we may infer from the ICOS that should be considered when we're designing the architecture? This is something that is yet open. So right now we are in this sort of discussions, and this is the kind of, say, food that is feeding the design of the architecture, right? And this is where we are now. And of course, we expect to contribute with other projects that are also here, and also with the technologies that have been presented before in the talk before, right? And that's it. Thank you for the opportunity to present the project.
Thank you so much, Xavier.
So, brief introduction to FLUIDOS. So the main idea behind FLUIDOS is, let's start from a problem. And the problem is that we have rigid silos. I think everybody knows about rigid silos, but in our case, this is even more important because we selected Kubernetes as our target platform. And when you deploy an application in a cluster in Kubernetes, you have to select the cluster, and that's it. So what we would like to do is to create a sort of borderless continuum so that when you create an application, that application can span across multiple clusters exactly in the same way as we do for single cluster application. So that's exactly the key point here. So it's not that we cannot use multiple clusters at the same time. Definitely, with the current technology, we can use multiple clusters at the same time. The problem is that we have to do the deployment in a specific way so that both clusters are addressed. And the application has to know exactly that is running into different clusters. So it's completely not transparent. So the main idea behind FLUIDOS is that we want to create a sort of borderless Kubernetes. So extending this idea, we have cloud, fog, edge, and so on. This borderless continuum should be available at multiple levels, from the edge to the fog nodes to the cloud data center. I don't care. I would like to offer to my developers and DevOps and so on a very simple abstraction, which is a Kubernetes cluster. That's it. And do the magic. So behind that, so in order to create this continuum, should be left to Kubernetes, and the magic is FLUIDOS. So how do we plan to do this? Okay, there are several ingredients. This is basically a picture that is the current draft architecture that we're defining, because the idea here is that everything is a Kubernetes cluster. And a node can be a Kubernetes cluster, but also an aggregation of nodes can be seen from an upper layer as a Kubernetes cluster. So everything is reduced in the end as a Kubernetes cluster. And we have this kind of hierarchical organization of clusters that allows us to scale and to create the continuum. The other, I think, distinctive characteristic of FLUIDOS is that we leverage very deeply another open source project that is LECO. LECO, you can see on LECO.io, is a very promising framework based on Kubernetes. By the way, has more than 700 stars on GitHub that allows to create a continuum. So given two clusters, is able to create this sort of virtual continuum that spans across both, with some properties like ownership. You can control where your job are deployed and so on. But this is something that is real, is used in production. And in the FLUIDOS project, we plan to leverage this open source component as our base layer for creating the continuum. What LECO does not provide is intelligence. So it's creating this virtual cluster, but it does not know how to create. So something on top of LECO has to say, okay, create it this way, create that way, create with that other entity, join this hyperscaler, join the cluster of this other cloud provider, or whatever. So basically, LECO right now does not have intelligence, and the intelligence sits on top, and is our project, FLUIDOS. So we have different components here. So the first pillar is we have an extensible modular node with resource agnostic abstraction capability. What is a node? A node is actually a cluster, and physically it can be a physical node, an aggregation of nodes which become as a cluster, but from the top level is still seen as a node, and so on. The second, we have this kind of borderless continuum through intent-based, scalable, and fluid decentralized operating system. We have no single point of control by design. We don't want to have a single point of control. Everything is decentralized, and everything is driven with an intent-based approach that, given our ambition, should be scalable. I mean, it's pretty clear. Security definitely is the third pillar. We cannot imagine to have all the resources under our control, because especially if you go to the edge, there will be multiple actors involved, like the telco, like my factory that borrows resources from the telco. So when you have multiple actors, security becomes definitely very important on both sides. So both sides must be protected. So definitely the third pillar is security. And finally, energy. We feel that energy is very important. By the way, we wrote the project more than 1 year ago, but we were thinking hard in terms of energy in two directions. First, because this kind of continuum will contribute to decrease the energy consumption. And in the second reason, because we can also target not just energy consumption, but also CO2 reductions, because we can privilege energy sources, green energy sources. Okay, so okay, those are the other topics that are there, but it's not so important. Final point before my conclusion is that we really aim at creating real code. So we have a distinction in our project that will be something that will be a prototype, but something that we would like to push into mainstream. So we committed in our project to do a given amount of work in terms of pushing our modification, our algorithms, are at least part of those in existing open source projects. We don't want to reinvent the wheel. We don't want to create something completely new from scratch. We would like to improve existing works, and to improve, we have to commit and we have to push code. Those are the partners scattered across Europe. I don't think it's so important. I mean, you know probably the names already. So that's everything for my part.
Thank you so much, Fulvio. We can go on with NebulOuS.
Thank you. Good afternoon, everyone. I hope you can hear me well. My name is Yannis Verginadis. I'm an assistant professor at the Athens University of Economics and Business, and I'm also a senior researcher at the Institute of Communication and Computer Systems in Athens, Greece. ICCS is a core partner of this project, of NebulOuS project, and therefore in this brief presentation, I will try to go through the main vision of the project. We are on the same cluster, obviously. We have started on September of this year, and the project duration is going to be 3 years. And as you can see, we have already allocated a significant, or we planned to allocate a significant part of the budget for open calls and financial support to third parties, which means that we want to extend the testing and the validation of our technologies across different business domains, extending the 4 pilot demonstrators that we already have. The consortium involves 16 partners from 8 different countries, and we have pilot demonstrators involving 5 different use cases, starting from windmill maintenance, city maintenance use cases. We continue with a second pilot that relates to sustainable management of infrastructure and freights in the general area of Barcelona. The third pilot comes from the precision agriculture domain, where we have some significant requirements for edge computing at the field. And the last pilot is related to crisis management and is led by a partner of the consortium in Germany. The project is coordinated by Eurecat, and ICCS is leading the scientific work. So the vision is to offer substantial research contributions in the realms of cloud and fog computing brokerage. So we envision a meta operating system that will enable transient fog brokerage ecosystems, and by that we mean that we would like to allow the dynamic creation of resource pools that might extend the strict boundaries of organizational units inside the same organization, or they can even cross the organizational boundaries and reach telecom providers, for example. The idea is to have a resource pools of public clouds, private clouds, fog devices, or even private data centers from telecom providers, in order to use them as the potential hosting environment for our low latency applications. And the idea is that we want to use all these resources in order to find the most optimal configuration of a certain cloud application. In order to do that, this is a bird's eye view of the architecture. We are at the beginning, and we do not have a very fine-grained architecture yet, but I have to note that the whole approach involves model-driven engineering approach, which means that we want to keep a model from the design phase, the design of the requirements of the application, of the potential offerings in the cloud computing continuum, and also at the runtime phase. So in order to keep the current context of the application at any given time and allow our optimization mechanisms to be able to find at any given time the best possible solution for operating and managing the application. with respect to the upper part that you can see here, we envision the development of appropriate modeling tools for describing the cloud computing continuum, for describing the application requirements and the data streams. We will not start from scratch. We have used in the past, we have extended DSL languages by using the Eclipse modeling framework. And we plan to work on that, but also to design and develop some semantic models that will lead the quality assurance part of this work. The first objective and the main objective of this project, as I mentioned, is the support for fog brokerage in the cloud continuum. And this means that we'll allow for the users of our system to express their preferences and then use multi-criteria decision-making techniques in order to come up with the resource pool that I just mentioned before, the dynamic resource pools that I mentioned before. In order to do that, we are going to offer some mechanisms in order to have the management of SLAs, the signing SLAs, and also enabling them over blockchain. And on top of that, we're going to have a very flexible monitoring infrastructure in order to be able to gather and process monitoring data across distributed and heterogeneous resources that might exist in the cloud computing continuum. The idea is to offer an intelligent application and data streams and IoT lifecycle management, in the sense that we are also interested to see how if data streams from the extreme edge of the network is being propagated, and how we decide to place processing capacity as close as possible to these data sources. The idea is to use the monitoring data and be able to offer self-adaptive and proactive reconfiguration of the application. In this domain, we want to offer a seamless experience for the user. And sometimes it is not enough only to react to certain circumstances or a certain service level objective violations that you might have. Yes? There was a question? Oh, no, okay. So the idea is that sometimes you need to predict the context, and you need to be able to find an optimal configuration of your application for a future time, in order to start the configuration ahead of time, right? Before experiencing any kind of problems. In order to build this, this solution will not start from scratch. We're going to build on open source tools and technologies that we have developed in the past. And we are certainly interested in examining some of the very interesting technologies that exist inside the Eclipse ecosystem already. And we are very keen on trying to reuse them or even extend them. So that's it from my side for now, and thank you very much for your attention.
Thank you. Thank you so much. We can go on with the NEMO.
Yes. Good afternoon, everybody. Thank you on this invitation and a very interesting discussion and introduction of the Eclipse toolkits. It's very useful to us as well. I'm Haris Kianis. I'm with Synelixis, and I'm acting as technical manager for NEMO. And with this presentation, I will provide you an overview of our approach. NEMO is the project ID card, where ATOS is acting coordinator and Synelixis is the technical manager. Starting on the 1st of September and lasting for 36 months, NEMO will receive around over 10 mega euros on EU contribution, with around 1.8 mega euros dedicated to cascading funding. NEMO will consist of 26 partners coming from 9 countries, and is anticipated to showcase its merits over 8 use cases deployed on 6 living labs and pilots. Obviously, we expect this number to grow when third parties will join us later on the project under the 2 open calls. In NEMO, we identify a fast-growing IoT ecosystem and ever-evolving applications that push beyond simple IoT and towards artificial intelligence of things. But in this new landscape, one usually identifies lack of support in a plethora of areas, such as security, trust, sufficient and real-time reaction from the edge cloud, as well as lack of intelligence closer to the data. Moreover, opportunities arise in the domains of digital technologies, business and operating systems, enabling massive deployment of IoT in heterogeneous environments, supporting smart application enhanced with privacy features by bringing on-device AI closer to data sources, high availability and flexibility when it comes to supporting technologies such as IoT, 5G, and ad hoc hybrid clouds, easy development and zero-code tools associated with data monetization and new business models. A sustainable solution is feasible by the engagement of relevant communities and large ecosystems. In a nutshell, our architecture, we offer transparent connectivity using self-organized healing network clusters by introducing meta-network cluster controller that will interface and replace independent and heterogeneous tools and protocols. NEMO secure execution environment will be managing the complete microservice lifecycle. NEMO AI-based meta orchestrator, which will automatically and in real time reconfigure the meta operating system setup at each node, either at the IoT edge or cloud, so that at the end-to-end the federation operates optimally, matching the application service level objectives and the policies such as CO2 reduction set by the meta operating system administrator. On the top, the Dev ZeroOps platform as a service builds on three main components, namely the flexible plugin and application lifecycle manager that offers over-the-air and on-time deployment of required plugins, the intent-based SDK that offers intent migration as a service, and the Mocha features that offers pre-commercial exploitation in a multi-user, multi-operator, and multi-tenant environment. NEMO introduces three vertical layers, namely cyber-secure federated MLOps, in order to provide efficient on-device security, present policy compliance to cope with different aspects of the application lifecycle, such as security, privacy, cost, environmental impact, etc. And lastly, cybersecurity and unified federated access control towards cloud-native cybersecurity interfacing various authentication and authorization frameworks. With respect to today's webinar, NEMO envisions to liaise with open source communities. Eclipse Foundation is a partner within NEMO, and other initiatives such as AIoT that we presented last week, as well as bringing in third parties such as SMEs, developers, and service providers in order to extend real life adoption of NEMO. Thank you for your attention. We invite you to join us via our website and our social channels. Thank you again.
Thank you so much.
So hello everyone, this is Yannis Genetis from the National Technical University of Athens, one member of the team that's gonna run the project. And I'm going to present you the Nephele project, whose main goal is to develop a lightweight software stack and a synergetic meta orchestration framework for the next generation compute continuum. So I'm going to be as brief as I can, so that I can cover well the time limit. So the main innovations of the project are twofold. So the first goal that we have placed is to develop an IoT and edge computing software stack for leveraging virtualization of ID devices at the edge, part of the infrastructure, in collaboration with the cloud, and to support at the same time the openness and interoperability aspects in a device-independent way. The second goal that we have placed in our implementation is about the development of a synergetic meta-orchestration framework for managing and coordinating between the cloud and the edge platforms that are available, so that we can schedule and supervision for the scheduling, supervision, and definition based on the adoption of a system of systems approach. So what the first part means for us is we have designed a virtual object stack that's going to include a series of implementation functions that are going to coordinate the device layer with the cloud and the edge infrastructure. So the higher layer of our architecture includes a series of functions regarding the orchestration management interfaces that are going to enhance scaling, deployment, monitoring, migration, and other operations that are related to the development and orchestration of these virtual objects, these entities that are going to manage the devices, and also a series of generic and supportive functions for managing operations such as authentication, authorization, multi-tenancy, and other virtualized functions that are going to enhance the operation of these objects, as well as IoT device-specific functionalities that are trying to implement the more of the business logic of the applications. The second part, that is more on the physical convergence to the IoT devices, includes the autonomic and ad hoc networking functionalities such as bootstrapping, self-configuration, self-healing, energy-efficient operations, and more, and also for handling issues regarding the interoperability of different models and the security and the security frameworks, as well as the management of the IoT devices, such as including protocol bindings, semantic interoperability, registration of the resources, etc. The second part includes the building of this synergetic meta-orchestration framework for managing a series of orchestrators, mainly of different players that in synergy are better off than individually. So a series of edge or cloud orchestrators are going to work together in order to transform the high-level goals of a hyper-distributed application to lower-level ones, and by leveraging also the virtual stack, the virtual object stack that we have designed. So the general architecture of our project includes the virtual object stack, as seen in green here, which includes all the operations that are going to bridge this gap between the edge cloud layer and the device layer, and also the synergetic meta orchestrator that we're going to develop, which includes this high level of orchestration between different orchestration entities, as well as the federated resources manager and the network computing, the network manager of the compute continuum, which is going to manage the edge cloud clusters in the infrastructure, as well as network-specific elements such as smart ID devices, core network, the radio access network, etc. And all this is going to include all these layers, the device layer in the Internet of Things, the edge computing layer, and the cloud computing layer, for their efficient collaboration towards the deployment of hyper-distributed applications. I think this is a brief presentation for including all these aspects, which we have already started developing and designing, but we're also very excited to see them coming to life. So I think that this is all from me. Thank you very much, and floor back to you.
Thank you. Thank you so much, Yannis, and thanks to all of the attending. I'm going to close this this webinar with a couple of remarks. We will meet each other in January, the 18th. So we have a date, and also it will be next to IPIC. We will not be in IPIC, but I will send you an update next week. So please save the date for the next one. And I'm going to thank you all for this webinar, for being here and participating to this, for the project, Frederick, Gael, and Philip that also made a wonderful presentation, and also from Open Continue. So thank you guys. And Philip, I see you. I don't know if you want to say something more.
No, just thank you, Rosaria, for managing this session, and thanks for all of us for joining. It was really a great pleasure to share this time with you, and looking forward for meeting you again.